there's a lens adapter ring that's custom, and they of course decommissioned that when they decommissioned the camera, but they made me enough for, I think I have 7 or something, and they're going to send me 22 more. And then this is that standard lens with that big glass for the wide field of view, and so I think our limiting magnitude I computed is like 7.7, 7.8. So it's pretty simple, really. Power comes in over these 4 gauge. So this is 12 volt power, which people have claimed I'm crazy for, but we run the 12 volt from inside wherever the observatory. The only thing that goes inside is a UPS and the power transformer, and then we run the power and Ethernet through these. This is a conduit gasket, and so it comes in here, which is just a simple fuse box. I have augmented this with a custom PCB just to make it. I finally found the right place to get these PCBs for a reasonable price. And so, I mean, that's one bit of soldering, but all you're doing is soldering dumb components onto a board. It takes 5 minutes. And then that way, it reduces a lot of the fidgeting with the cables. On the previous instruments, like I was running a wire straight from here to where it needed to go, and it had to be the right length, and the camera connectors really suck. You can't see because I've actually got these all plugged in, but here we go. This is the other side of the cable, and so there's 4 conductors, 2 positive and 2 negative, and they come out of the back side of this thing as 2 stumpy little, like half soldered, like I have never seen a cable so like they didn't bother to strip the insulation off, and before they tried to tin the leads, but they were watching TV, and so the leads are like just super wonky. And so I take, I have to take pliers and basically mash the solder and shape it in order to get it to plug in. But these connectors at least mean that nothing is soldered, and you can unplug it and plug it back in if you have to. And once you get it right once, it's screwed in place, and you hopefully don't ever have to screw with it again. Okay. So that's been kind of a nice innovation. I run 2 different sets of power. The fans, which if I plug in so there's a fan beneath each optical stack sucking air down, and then there's another fan that blows out these 2.
So there is nothing here basically underneath here.
So that's where the GPS antenna comes out.
Okay.
Yeah, so this whole box is just meant for cabling. All the interesting stuff is meant to be easily accessible.
Yeah.
And the fans are just for cooling.
Yeah. No. And so there's also, it took me a while to get actually the cooling right. Originally these were unpainted. So this is 316 stainless steel. So surgical grade, but like 3/8 of an inch thick. It's
How heavy is the thing?
Huh?
How heavy is that?
40 or 50 pounds.
Okay.
These are the covers, by the way.
So you have to, you set them up and you transport them with
this
the
gives
cover.
you a good sense of, here if you want to see.
Oh yeah, it's not much at all.
It's the first generation didn't have the handles.
Oh, well, that would be harder.
And then when you realize it makes your life easier, right?
Yeah.
Hold it. No, you got it.
Just set it down.
So are they, those are final ready, those?
Those
Like
have been
the
glued, not
glued.
sealed with a silicone. Okay. So the fancy thing that I'm trying to change to make this
Tools.
easier is I did the glue with this guy. And so it's really
caulk gun.
well, so yeah, because what you need is this perfect bead that goes all the way around. And so previously, I was buying the adhesive's called E6800. It's just the ultraviolet tolerant version of E6000, which is super standard. It's an amazing. I love the. It smells like shit, but it works great.
All right.
But I was getting it in a tube and squeezing it out of the tube, like my hand would ache for days. And I couldn't get like a perfect bead because my hand was just not strong enough to,
Continuously.
And so I bought this, which was a little bit crazy, I thought, but at the same time, I was finally able to get a solid bead all the way across. Because previously what I'd do is then I'd have to come back with super glue, cyanoacrylate, and fill in the gaps. And so that added a third stage to that, to just make sure that it was all glue sealed, and then I'd come back with the silicone to caulk it.
Yeah.
And so this is a little bit interesting because it comes out too fast, even with the smallest hole I can make there's the glue down there. And so what I ended up doing was basically feathering it.
Taken out the glue.
Okay.
And so I was able to sort of drag it all the way around and feather the trigger about like sort of a 50% duty cycle.
Yeah.
And get a good bead around the whole thing, such that when I drop the window in, like you could visually confirm it was 1000% sealed.
Yeah.
Interesting.
And that was actually I did it as a two-person process because since as soon as you basically apply enough pressure, there's kind of an inertia to the glue. So when I try to stop, I can lift up, but what I did was I had my friend come in with the cardboard and just guarantee that nothing else ended up glued. Yeah.
Got it.
Okay, so you glue this window, then you put the silicone around, and those are supposed to get to be washed by whom at the station? Over time.
By nature.
Okay.
I usually clean them when I'm there, not even always. But you'll see that like when we get rain, it was designed, the instrument naturally with the field of view sort of, our goal was to get to 30 degrees above the horizon where extinction starts to really take over from the zenith. And so that angle was just sort of perfect for having a nice drain.
Okay.
And so you'll see it'll rain somewhere and like the windows will just look great.
Oh,
So I don't think I've ever asked somebody to go out and would you please clean the windows.
Additional question. The field of view. How do you decide the field of view? How do you move the orientation of the camera to set it up? Or they always standard? Like,
It just is.
so when you send me the diagram where you have the coverage and so on, you basically consider the orientation of the camera and you never move it. You just move the station, maybe in location to point toward the north, the south, and so on, but that's all.
You install it in the right place and you never move it again
No, but to optimize it, you do that
on the computer.
on the computer.
And
Okay.
then when we install it, I know what elevation and azimuth I want, and you set it up, and we got it right within half a degree on our first installation. And since the field of view is 75 degrees across, like if one camera is at a degree off, or if we're half a degree this way, like who cares? There's going to be a lot of overlap.
Yeah.
And so that level of traditional precision is just not necessary, I think.
Okay. Other stupid question. So right now they're on the wheel here. Okay.
Yeah.
When you install them later on, so the wheel is just to be able to move them down and
To make
up
it
and
easy
down.
to flip them around.
Okay. Then you go remove them from the wheel. So how do you attach them on the location?
You can see here, it's a C-beam. I've got mechanical drawings and better pictures and that
So
sort
that
of
they
stuff.
all standard.
So-
You need a superficie of what?
There's
typically.
these pins right here allow the instrument to pivot. These things right here are the course elevation adjustments. It's every 7.5 degrees. And so the alignment is pre-calculated. I had written it up. See, like that's what was calculated for Hawaii. And so, I knew which hole I was using, and I fill in the rest with bolts from the back. And then so the C-beam, you stick it on, and then you bolt it on either side, and that And then the fine adjustment comes from the feet, which I probably have. Let's see.
Is that this? Oh. So
No, this was actually meant as a rod to kind of connect between the C-beams, just to give the mechanical engineer thought it was a nice idea, but it's kind of superfluous, and I mean it makes a nice weapon, but it's kind of expensive.
everybody knows what a C-beam is?
It's like an I-beam. Two C-beams make an I-beam.
You're gonna have to show me this.
It's
I don't know if it's my English second language, but I have
it's
no
a
idea.
plate shaped like a C.
Yeah.
That's it.
Okay, well, you're gonna show me.
Okay.
Yeah.
Or half an ivory, like he was saying.
Yeah. Okay, so the foot.
So the feet are large metal. This is all in storage because I don't need them to go
Yeah.
deep.
So
This
you
is
have
all
them
covered.
ready and
So
so
the
on.
foot pad is about is pretty much a square foot, and it's this same steel. And then there's let's see, do I have them here? Yes. These are the handles. Here's a foot. So the bottom part screws on to the metal foot pad, and then you adjust this up
Mm-hmm.
to set the height of the C-beam,
Right.
and then you bolt it on from above. And so this gives you your freedom to have the, if the ground isn't exactly level or whatever, or if the instrument's tilting, so this is what the instrument sits on.
Okay.
So it's just sitting there free. It's not screwed into a concrete pad or anything like that. It's just
Nope.
sitting on the ground on its own weight.
Mhm.
You know?
It's heavy enough.
Say 50 pounds.
Yeah.
Well,
I mean,
no,
where is it going to go?
This is 50 pounds, and that's 50 pounds. The whole
like
whole
everything
instrument
else is
is
more.
like 200. I've never calculated it,
Yeah.
but
Somewhere around there.
Yeah.
Okay.
there are holes in the foot pads meant to allow us to bolt it down or something like that. But
Probably not necessary.
anything that would cause us to move would destroy the neighboring area. So we've at the two sites we've been at. I mean, so like this this structure you see here, this was designed special for Hawaii, and only there's one instrument up here, and then this instrument sits down there. And because this one had to see over the railing, we built this thing to raise it up.
Yeah.
We modeled that thing to 130 miles an hour. Like, and
It's not going anywhere.
yeah. The with the pixel size being what it is, if the top of the instrument rotates by 100 microns, I think that's a pixel. So one of the things I designed early on, so you should see the first instruments. This thing was made out of centimeter thick stainless steel.
Oh wow.
It was really damn heavy. And the point was to be hunkered down and heavy. That's why everything's not aerodynamic, but is meant to be just sort of as minimalist, hunkered down, solid. Nobody's going to move us, cause us to vibrate, anything like that.
Right.
So that we just sit there and do our job. Mostly because on mountain summits, you do regularly get 50-mile-an-hour winds.
Yeah.
And you don't want, that's why the accelerometers are there to measure if you're moving, so that you would know, what's going on. We do take the registration frames, but that's only every 15 minutes.
Okay.
And so the idea is just to hunker down and never move again.
Okay, so let's go back to this. Air, GPS cable,
So
internet, and
power and internet would come into
Uh-huh.
here. So this is the first instrument. So it has a hub. It's actually a router here, and with a firewall and everything. So it's its own. The cluster of instruments is its own private network, with all of the computers inside of it, protected from even the observatory.
okay.
And so you just need a single IP address, an Ethernet cable, and the 12-volt power, and they come in. GPS antenna. This will have power and internet coming back out and going into here, and that's how these guys will connect.
Okay, they're connected together, and this one is using the internet of this one as a Wi-Fi internet, no Wi-Fi, directly internet.
Yeah.
Okay.
Yeah, they don't like Wi-Fi
Yeah.
wireless technologies at observatories because they do things like solar observing. Or,
Okay, so at the bottom of the camera, I can see the PC,
yeah.
right? The router is this one.
Yep.
Okay. Everything is. This is 3D printed.
Yep.
And you
Right
have
there.
3D printing enough. I'm assuming you have
Yeah,
3D printed 10
so-
of them already.
I've got about 7 instruments worth of parts,
Okay.
all in those 3 large plastic bins there. I actually stopped printing because I just ran out of bins, and I thought I'm far enough ahead.
Like you can
Why
make
why
more
why bother
whenever you-
creating a problem
Yeah.
for myself?
Yeah.
But it's all of the plastic stuff was going to be about a year of 3D printing. So I've done, 8 or 9 months of the printing, and if today magically we wanted to build all 10 instruments, then it would take me 2 months to print the last couple instruments worth of parts.
You do it yourself, the 3D printing? Oh my god, such a geek. He has his own 3D printer. Okay.
It was a cost thing. So actually, the first
Yeah, it cost a fortune. We did
He's
it.
gonna get us a 3D printer now too, right?
Now we're gonna take this one. Look, he can control it with his phone.
the first brackets, I actually got a company in Idaho to sponsor, and they're printed with this carbon infused nylon, and it's, a little nicer process, and it was like $10,000 of 3D printing that they did for free.
Wow.
And then the person I was working with got fired for doing bad biz dev deals.
What a surprise.
And so like I just I looked at other places I could get stuff printed, and like this is like a $2,000 printer, or I could pay like $2,000 per instrument. And so I'm like, well,
Just better decision.
Alright, so we can use your printer to print the rest of the
and
instruments
my
in the
plan was
future?
I'll just keep printing.
Yeah. Okay.
We can move it to your office if you want. That way you can pay the power bill.
Yeah. Someone would be very happy. Yeah, I have solar panel in my house too, so okay. We think about that. But the solar printing is important because you have some to do.
I made this because it saves about 20% of power.
Oh.
Because in the polycarbonate, in order to get the parts to print reliably, the base plate is heated to 110 Celsius, and so keeping that heat in drops it from about 470 watts to about 400 watts.
Keeps it cooler.
Yes.
Okay, and
Yes, it
how
was getting
many
quite warm in here.
how many
My engineer senses were tingling.
camera we have them? How many objective? In fact, the word in
Lenses?
English. Lenses we need.
Well, I have the 4. We're gonna need
6 of them.
16 more.
16. Ah yeah, it's 2 camera. Yeah, of course. Yeah, 8. Phantom 2. Okay. Computer, you say you have it. Router and so on, you have it.
Yeah, so I have, I think, 2 or 3 more. Since Arizona's consuming one, I think I'm going to need to buy more of these. And so with backing up, so originally the 10 instruments were going to go to Ferguson, Arecibo, Canary, LSST. And so that meant only 3 new observatories, so I bought 3 routers. But Saudi Arabia has come into the picture, and when I computed how much of the sky we're covering with the original plan, it was like 48%, 47%, and I'm like, that's fucking awesome. But then, as I was looking at some other things, I was like, well, wait a second, I can get us up over 50%. We could cover half the damn sky. That's kind of a cool milestone. And so then I was like, well, shit, if I can get us to 50%, if we build this 11th instrument we're talking about, how far could we get? And so if we basically stretch it out horizontally across the Earth and go all the way to Bhutan with an instrument looking west, that gets us to 58% of the sky covered. But now you're talking 1, 2, 3, 4, 5 new sites. So I need to buy 2 more routers if that's what our plan is. And this router is old and sucks, but it fits and it works, and I don't see any reason to change it.
Yeah, the goal is to create them, to make them strictly identical, so we don't have to deal with, which router we had on this one, and it's a fucking nightmare.
Yeah, there's already differences between all of the instruments, but they're relatively minor, and as long as you can tell the difference between a red wire and a black wire, or a Raspberry Pi and a PC, you're generally fine.
Okay.
This, what is coming from, you said?
Huh?
Where this is coming from?
This is made in East Bay Machine Company in Pleasanton.
Ah, that's the one you mentioned to me last time, yeah. Okay.
Yeah. So, yeah, the 10 enclosures was like a truckload, a literal truckload of a ton of stainless steel that all arrived. And we've got all the mechanical drawings, and that's why this is up here, because each one of these screws can be different. And so I've kind of highlighted the notes for, and that's why I made the wall of screws up here.
Okay.
Because I think if you're, my original plan was one of the SETI board members has a warehouse in Mountain View, and I was going to store everything there, and I was going to come there and just like assembly line the covers,
Yep.
and just do all of the windows and just do it all in one day. And then he said, you can't do that. So I got a storage area, and that's where all the stainless, everything that's not here is, it's at like 14th and Dubose, where that skate park is under the highway.
Mm-hmm.
And then he calls me up a month or two ago, and he's like, actually, I need your shipping cases out of here too, because we've got these big 3 foot by 3 foot by 6 foot shipping cases that fit the instrument fully built. You just screw it down onto 2x6s and ship it that way. And so I got another storage area at the same place and spent a day driving a box truck down to Mountain View, because you can't even fit 2 on a pickup truck.
Oh, wow.
When we shipped the instruments to Hawaii, we built a platform in the back of my friend's pickup truck that basically brought the bay up to the level of the walls, so that, I mean, they only overhung by like an inch, but there was no way to fit 2 instruments in one pickup truck.
Yeah.
You ship by
You
air?
ship-
By sea.
I see.
You ship them fully mounted like that?
Yeah.
Fine. Okay. With the closure,
And-
everything.
And the only problem was when they stabbed one of the shipping crates with a forklift and punctured the transformer.
Oh, jeez.
How they do that?
And then what was really awesome, after having the instrument sitting in here waiting a year for the pandemic to clear enough for me to go to Hawaii without spending 2 weeks in a hotel room. So we go there to install, we find out they punctured my transformer, and we're like, no big deal, buy another one on Amazon, $200, it'll be here in a couple days, I'll just, we'll do all the installation and then I'll just power it on in a couple days. I go all over the island to get the transformer because it's like the last day and it's finally showing up, and I need to get it that day, not the next day when I leave. And finally get the transformer, I run up the mountain and install it, and then the instruments don't work right. What the fuck? And I keep turning it on, and like the instruments are just behaving really weird. Eventually I look at the transformer and they sent me the 240 volt, oh no, not 240, 24 volt transformer, not the 12 volt transformer. I didn't check the model number.
Uh-huh.
And I blew out the fans, and that was fortunately the only damage I did to the instruments. I think.
And he stayed 2 more weeks in Hawaii.
No, I did 3 trips to Maui in like 3 months, where I was there for 2 days, sitting in a concrete bunker on top of the mountain, where
Great.
it's fucking beautiful, and I could spend a ton of time there, but trying to work up there for like 8 hours at a time, and where am I going to go to the bathroom, and what am I going to eat when like there's nothing.
Aye. So now I'm gonna record you telling us roughly how you set up everything, how you mount everything, which order. So what do you do?
It's basically bottom up.
Okay.
There's a bunch of prep that happens to the base. This is kind of the 2.1 generation enclosures, but every single screw hole has to be tapped and cleared, and they've been doing it. But you have to test and make sure all of this hardware works, because you don't want to find out that like you need to clear out a hole once you've built everything. But yeah, you just kind of start. You actually start from the inside with the exhaust fans, although you don't have to. Nothing. You can always disassemble or do things in a different order. But I figured prep this so that it's as done as possible, and then just build it up. You're seeing it right now without the Raspberry Pi, because one, I'm on the stage of needing to get the sunshade so that it slides better than this, I do have. I finally broke down and bought an adhesive or a lubricant that, you know, even when I got it sort of what I felt was perfect, it wasn't just sliding frictionlessly. And that lubricant is awesome, but the only thing is you have to kind of wait a couple of days for the off-gassing because you don't want anything to transfer onto the transmission grating. But once I got that whole process down, the sunshades have been super reliable. And then once the instrument's built to this point, the Raspberry Pi goes back here, and it's sort of the last bit of complexity. It's got the so these are motors and cases and Raspberry Pis. This is what I'm looking for. So these are a little more constructed. I thought I had one in here that was pretty constructed. So this is a good illustration of what the Pi looks like. So the blue board here is the motor hat, and you just put the 4 wires with the stepper motor into here. And what I do though is, you can't see it very well, there's kind of half of a proto board in here, and I use that space to do the 12 to 5 volt conversion. And so there's a little bit of a circuit that I solder onto here, and then I run the power. So all you do is bring in the 12 volt power to here, and this is what supplies power to the Pi and the whole stack. But the motor hat gets its own direct power because it actually draws significant power. This is the GPS accelerometer board, and this is the PPS wire that gives us that super accurate clock. This is a USB cheap, like $5 storage device that just means that we're not writing to the disk for the Pi, because Pis, I don't know what it is about Raspberry Pis, because ext2 is a journaling file system, so it shouldn't have a problem with sudden power loss, but it is possible to brick a Pi by killing it at the wrong time. So we do all the logging to this device, so that way there's just no reason to ever write to this disk, and we haven't ever had any problems. So this isn't read-only, but we haven't ever had any problems with Pis getting bricked because of sudden power loss.
Right.
And we have had plenty of power events at Ferguson. They're, even though it's, you know, Sonoma County, they're up in the hills. We've had big fires. We've been unpowered for a month at a time. We've had, I've shown up there and seen the alarm system for the observatory going, and I went and checked the UPS, and we were getting 56 volts in from the wall at that point. So like, it's a tough environment, and that's why we have a Mammoth UPS. Actually, I have the real UPS downstairs in my office, just because it was a better UPS to use on my computer than the one I was using, so that I would use that one up here, and that way I can still test against it. So that we have this big ass UPS with a remote control board, so that you can separately connect into the UPS and hit the master switch and just reboot the whole thing. I had originally, if you see these slopey parts here, this was a second generation design because I put in relays that allowed me to toggle the cameras and for the Pi to toggle the computer. So I figured that way, if things go wonky, I just connect into the other device and I can power cycle it. The problem is the relays are less reliable than everything else. And so the third generation design is fuck the relays, use the big master switch if things go weird, because it's like once every 4 months that like something won't work right. And you
turn
just
it off and turn it on again.
Okay. The Raspberry Pi is quite complex, the installation of everything here. I mean, I know you say it's easy, but
Yeah.
plus the power supply, etc.
You have to know where all the wires go. I mean,
And this is documented somewhere?
yeah, I have pictures and labels.
Okay. Okay, and this?
So that's the top. Here. Actually, one that's already installed here.
Okay.
So that's not working. No, because I've got it backwards. That's why.
Which operating system you have on the Raspberry Pi? You put
Linux.
Linux?
Yeah.
Which one? Just doesn't
Whatever the
matter.
latest is at the time.
Okay.
We had started to upgrade the software process to have like a proper build process, but the way I build the pies is take the image from the last pie and
Okay.
install it and
And
just modify it for the next one. So that's roughly how it screws on.
Mm-hmm.
And then it attaches back here like this, and that's the camera we were looking through in my office.
And the connector to the motor is this.
Yeah. So these guys come around, and like I say, they'll connect into the first
In
motor
one of
port
those, okay.
right there, and then the GPS antenna plugs in there, and power comes in there, Ethernet, and then we don't generally use this, but sometimes I use a spare USB port. Like the first instruments don't have this airflow designed the way this is, with the fans pulling air down, and so I have one of these fans with another manifold, sort of like the one that's behind here, with tubes that allow me to suck the hot air from the top of the instrument down into this chamber so it can get exhausted. So the first ones are the most different. To the layperson walking up to this versus Hawaii, the thing you're most likely to notice is like this or the relays. That in Hawaii, all I did was wire the relays out. I didn't even take them out of the instrument.
So this one, when you planning to ship them?
Honestly, I would like to finish them up in the next two or 3 weeks,
Okay.
because I'm going to Hong Kong to celebrate my wife's birthday the second week in April, and I'm theoretically supposed to start this new job when I get back. So I would like to get these finished up. I have kind of purposefully not done anything on these for the last week or so, because I thought it was nice to be able to see them in the half-built state rather than you having to imagine what it's like when the pie's not on and
Right.
all of that sort of stuff. I thought they were kind of at a nice point to see without quite as much wiring and crap on them.
When do you work on this? During the day, in the evening, overnight? Because I get messages from you at 3 a.m. So I have the feeling that you work overnight, right? Right. Good. All right.
I'm more likely to work on them during the day because, like, my favorite tool, where did it go? I saw it kicking around here. Here. This. It's fucking awesome.
Yeah.
Because there's all of these little screws.
Yeah.
And if you sit there doing that,
Sammy,
Your wrist is gonna
Sammy.
explode.
so yeah. And that one I found is the highest torque of the electric screwdrivers.
'Cause I'm done with this also.
Right.
Hi.
And actually, I've got the big boy version of it as well. Because when you're building an instrument, jeez, you know, like all of the bolts that hold everything together, like you just go.
Yeah.
Sammy?
You change the tires in the car when you're done too.
Yeah. So
Stealing everything.
yeah. These things, those two are super clutch. That caulking gun I bought just for this, so if you're going to build instruments, I can just lend you
Yeah.
that.
Okay.
But
And
it's
that's the tool thing. Okay.
M10 down to M3, various lengths.
We'll see that after.
I actually I was planning on putting labels on all of those little things, so that way it'd be just even easier to know these are the exterior bolts, these are the things that hold the sunshade down, you know, that sort of stuff. Because there are some various lengths, like this one is shorter than that one. But there's a bit of a trick. You want to be careful when you're inserting these screws for the first time, because there's more friction the first time, and if the screw comes in fast, it can actually get hot enough to melt the plastic and then get fused in.
Yeah.
So, like, either doing it by hand or like bringing it in some and then bringing back out just to let that heat, drop off even for just a second or two is enough to keep it from getting fused. But like, these are imperial bolts because that's the camera, and there's one in here, one back here, and then these 4 to hold that all on. And then I used the same. Well, actually, it was a mechanical engineer that used the same bolt there. So it's all metric except for those
For those one.
10 bolts per camera.
So the camera, you get the cameras pre-assembled, so you don't do anything with focus or.
Well,
The
I mean,
light
the
path
lens
or-
has to be focused.
Well, okay, so you do adjust, but you can adjust that all from the actual lens focus. Like you don't have to actually move any of the optical components.
When we replaced the camera, I had a few steps about like I made sure to have him be really careful with the focus, and he pulled it off, swapped the camera, rebuilt the instrument. That night I connected in, planning to, try to have to work through having him refocus, and they were.
The cover here, they go on this and they get attached with that. Okay, so you can remove them, do the focus, put them back.
And actually, to your question about the hardest, I forgot. So there's alignment holes in here. Get so I can see it. So here and here, and that one is a hole rather than a divot. So you can see they're kind of gnarly. That we spent significant time with the mechanical engineer and the fabricator. So stainless steel is notorious for moving when it's welded.
Okay.
And that cover is made from one giant piece of stainless steel that's welded and cut and welded and bent. And so we tried to get it so that everything lines up perfectly with these pins. They don't.
Yeah.
It's better, but they don't. So for the ones that went to Hawaii, I went through about 10 Dremel bits moving these holes. They did get better. There's some other alignment ones down underneath. So I think we fixed 2 out of the 3 areas, but this is kind of the last area where, even though these things seem quite straight, those things are done like super CNC precision. You end up having to like make the hole a bit bigger. And so that was another place where I
You bought a new tool for that, let me
changed
guess.
the process and got this fancy bandsaw that allows me to get in there and trim off that bit without having to do it all with a drill.
Yeah. That was going to be my next question. Is there anything you had to machine? And that seems to be the one thing.
Yeah. It ain't pretty, it ain't fun, and like, you're going in there and shaving off like a millimeter on the side that you think is not fitting right. Then you have to lift the cover up and set it down and try it, then put it back, and you're like trying not to scratch the paint job, and so you definitely want to do that before you install the windows. And that also means that like this cover is mated to this instrument. I've never tried to switch them over, but I know that the way that I have to modify them feels different in terms of where I'm trying to move the hole.
Unlikely to match up.
Yeah.
Okay.
I mean, it's possible that the bases are perfect
Right.
and all the errors in that, and so even though I'm doing different operations to that, it's different paths to the same point.
Right.
But just for my sanity's sake, I've just never.
Right.
I always just keep it. This one goes on that one. Don't ever change. This is the bottom plate. So you see the piano hinge.
This is a piano edge, okay.
So the main way you get into the bottom is to undo these 3 things. By the way, this is called the Steve screw. Because we got to Hawaii and there was only 2. And Steve was like, I don't think that's good enough. I don't think you're going to get a great seal there. And so Steve drilled and tapped that hole on top of the mountain. So
Steve Bordeaux.
Yeah.
Oh, I didn't know he can do that.
Yeah.
That's cool.
So now we call that the Steve screw. But so this is the normal way. You just pop down the front
Okay.
and sort of you get that kind of access to underneath. But if you really need to get more access, then you pop off the two things here and the whole bottom will drop out.
I see. Okay.
Generally, you don't really want the whole bottom to drop off, but usually these things are low to the ground, with the exception of IFA2 here. Usually this is a couple inches off the ground.
Yeah.
And if you're really trying to reach in under, like, I spent an awful lot of time cramming my arm into the smaller area, such that for the second generation, I told the mechanical engineer to give me better access. Because, like, once in a long time, like, if you needed to replace the gasket here, very rarely, but occasionally you need to reach all the way to the back. And my arms just weren't comfortably fitting back there.
Yeah.
And there's a what I haven't done here is a seal that goes around, a gasket that goes around here, that basically just traces that. Actually, I put it on the instrument, I think. But making sure that everything is watertight and bug tight. I've already done, to your question about annoying things, 2 of the 3D printing jobs are annoying. So getting this stainless steel mesh, figuring out the right mesh in the first place was a pain to get the right airflow while feeling like I was going to keep bugs out. And then, you know, I make a template and I cut it out of the stainless mesh and then I put it in here and then I super glue the shit out of it. And try not to have a headache the next day. These are all done.
Okay. Great.
The other one that's a pain is the sunshade, because it's too large to be printed in one piece, and so I print it in 2 pieces, and then I join them using glue and paper clips as sort of cotter pin in order to make sure that I have a mechanical strength, because long axis of that thing. And then it all has to be perfectly sanded and smooth. And then I put the mirrors inset into the thing, because that just helps me reject a little bit more heat. You notice this paint is different than this.
Yeah, I did see.
This is all powder coated, and it's bulletproof, and it's awesome. This is a fancy paint that sheds heat.
Okay.
We were required on Hawaii to be white to match the building, to visually impact the sacred landscape as little as possible. But the covers in Sonoma are this same white, while everything else is just naked stainless steel.
Okay.
Because we didn't figure we needed to paint it.
Yeah.
But now we're like, well, screw it. We'll just make them white and shed more heat. But this is fancy. In the windstorm they had 2 years ago, it blew around rocks so big that it chipped the paint as big as a dime or a nickel, and you could actually see the impact of the stone at the center. It looked like somebody had literally shot the instrument.
Wow.
You could tell the direction everything was coming, because from one side it looked perfect, and from the other side you're like, whoa, dude. But all of this is like completely intact. These lines are a new thing. That was part of, so one of the windows at IFA, Institute for Astronomy, is cracked. It's a hairline crack. There's no water ingress, but when the moon's at the right angle, it does catch light, and I don't think it's interfering. I mean, it's obviously degrading our sensitivity when we have a bright source over there. But the reason that happened is here they don't go through any thermal cycling. And what happened is it wasn't perfectly flat, but I sort of glued it in place the best I could. But then as the cover moved around, it cracked the window partly.
I see.
And so in order to keep that from happening again, they cut these grooves in here
Give it room.
that keep the heat from traveling, basically, as they're doing all their welding, because the bracket here, there's a machined bracket that gets welded onto the back of the cover,
Yeah.
so that the window can sit in it. And so when they're welding that, the heat doesn't transfer and cause the whole thing to move as much.
Yeah.
And those windows dropped in super perfect and great.
Nice.
But this is now a spot for water to accumulate and then start growing moss or some other shit. So my plan, and I haven't even started this, and actually Steve Bordeaux I think has some good ideas, was to fill that with like a red epoxy.
Yeah.
Because you want to fill it with something. You could just fill it with silicone, but if you're gonna fill it, I figured one, epoxy will do a better job of filling the whole thing versus trying to cram silicone in.
Yeah.
And two, I figured if you're gonna do epoxy, then make it red and make it look awesome, because it'll just be like part of the Laser SETI theme. The instruments do get we have a little Cricut, like a CNC arts and crafts thing, and I make vinyl letters that say Laser SETI that go on both sides of there, just for
Branding.
whether it's donors or so that somebody, if somebody at the facility wants to know what the hell is that box.
Yeah.
So that's one of the last steps, and it's not super hard, but it's been surprisingly resilient. That stuff has not come off.
Awesome.
That's certainly a lot of it.
Okay, so what we're gonna
the main
do-
thing is it's a whole lot of steps, but none of them are very hard. But like if you have to like get the right tool and figure out where the right bolts and where did I buy enough of these bolts and that sort of stuff, like that's where building them two at a time is so much more laborious.
Yeah.
And I think the interesting opportunity, if you have the space, we take everything out of the storage. We take, I don't know, maybe I'll finish these, but like this box and basically everything up to here is all supplies. That is all parts. That box is the windows. I've got the transmission gratings. So I would suggest maybe we just take all of this stuff, and if we could get like enough table space to put 8 of these things, then we could just assembly line stuff. And then I can even come down for a day and we could just like bang out a whole bunch of shit.
Okay.
Um,
I think that's what we're gonna do. It's gonna be easier.
yeah,
Okay.
there are certain jobs that are better suited. Like when you're assembling shit, like nobody else can generally help.
Right.
Once in a while, it might be nice to have somebody like hold a wire with a third hand, but
Yeah.
most of that's hard to help with. But like that's a 2-man job, and maybe just having people work in parallel.
Yeah.
And that way you're pulling out the same set of parts and doing the same process, and
Not having to relearn different steps.
yeah. Because that's the thing is I'm just sort of constantly context switching between different kinds of bolts or screws, or I'm making wires now, or I'm doing this, and so it's just hard to, you spend so much time in the switching.
Cool, man.
Yeah.
I think we're good.
Yeah.
Took already a lot of your time. It's a lot of information, so
Yeah, I need to absorb a little bit. It'd be cool to see the docs that you have. If
Mostly pictures.
okay, pictures are great.
Yeah.
The
but
pictures
to,
and manuals.
to try and match, to look at that and see what makes sense and what I'm totally lost on that I've forgotten from what you just explained. If we have to train, we're gonna have to probably train other people to do this.
Yeah, so I have like a master Excel sheet with like the bill of materials. Anything I buy that goes into the instrument goes into the spreadsheet. I have a link to Amazon or wherever I bought it, and then that way, like there are times when I go back and refer to the manual for something of like, what's the current limit on that, or something when I forgot, or I'm changing when I'm investigating a new idea. That's actually what this is I was looking at making my own dehumidifier. These are Peltier coolers. And so I was thinking if I put it here, sort of squished it in there. So this is a bolt hole that we don't use that goes below. So I was thinking that this is small enough that you could fit it in here and you could basically help pull moisture out of the inside of the instrument.
Right.
Because we do get some nights where you can tell because this camera will get a clear view of the sky and this camera will be fogged in or like halfway fogged in.
okay.
And so you can tell that it's just moisture, dew, condensation forming on the windows.
Is that, this might be stupid, is that a way that just because of the way it's designed, or is that like environment sensitive and like you could get the humidity on the other side? or is it
Well,
indicative of?
One camera.
I think it's
Yeah.
I think it's because if you're right at the threshold where if there's not enough moisture, so there's an air filter that goes in there,
Yeah.
and if there's not enough moisture, then it stays dry inside.
Right.
If it's raining cats and dogs, then one, there's clouds and I can't even tell the difference between clouds and condensation.
Right.
But there's a middle ground sometimes, not very often, but sometimes, where I can tell it's condensation because it's only partial.
Mm-hmm.
It's only in one camera or something like that.
Okay.
And so, even though the filter cartridge has louvers to kind of keep as much water from hitting the air filter as possible. But like in a downpour or like when you're sitting in just 100% humidity air
Stuff's
for
gonna get
days,
through. Yeah.
eventually moisture is going to make it inside. And there's really just nothing I can do about that.
Okay.
Otherwise, you'd have a cooling problem.
Yeah.
And so, I had thought about.
So you are
making-
thinking about that, meaning that you're gonna test it for the Arizona stations?
It's so. That's already my second design. The first was like hacking off the shelf personal dehumidifier. It's certainly doable in terms of. I found a. What's it called? Nipple's not the right word. It's a thing you can screw on that you could attach a
clamp?
to. Huh?
A clamp?
No, you can push a tube onto it,
Okay.
a connector for a tube.
Yeah.
Yeah.
It tends to look like this with little sort of barbs.
Yeah.
And so I found the right size of that so that you could screw that into here, and then you could make a drainage duct for that fed the water into there, and then you could then feed the water all the way out to the bottom.
Mm-hmm.
Actually, my plan was to drop the water into the exhaust manifold, because that way it's protected with the screen.
Yeah.
Because otherwise, I feel like the water could accumulate, and then you could have moss or other sorts of
Right.
contaminants block the egress, and then you'd have a problem with your dehumidifier.
Mm-hmm.
But I haven't.
Okay.
I just haven't had the time to spend on it, and like, it may be a dozen nights a year where I see that. It's not a huge improvement, but it just bothers me that we could be observing if it, or I need to continue to improve the pipeline to handle things like that. Like what right now, I'm just sort of manually looking at the result of the pipeline. But I want there to be more to sort of finish the automation so that you could know, did I see that part of the sky or not? Like imagine we see an event, but there's a cloud in that part of the sky for one of the observatories. We wouldn't see that event, assuming it was a real thing, but we wouldn't want to throw it away just because there was a cloud there at the time. And so I want to start to make it smarter so that it can, even though right now it's already kind of highlighting the interesting things, that it's possible that we could discard something that we shouldn't because it's clouded, or maybe that camera's off. When that camera had to be replaced, it took a little while to get it replaced. So we wouldn't want to discard something because, well, no, the other camera didn't see it. Couldn't have been real
Right.
when the camera was offline at the time. Things like that.
Yeah.
All right. Cool. I'm ending this.